Let us move on to next example. Falling object with air resistance. This is our number 4. A falling object with air resistance. Suppose we have the following case. Just illustrate this with one example. This example says an object of mass m is dropped from a hovering helicopter. Find its velocity as a function of time and assume that the air resistance is proportional to the velocity of the object. Very well, let us begin. If G is the gravitational force, and it is a constant, the downward force like F on a falling object with mass m is given by mg minus k times v. V is the velocity and k is the constant of proportionality. In this case, using the Newton's second law of motion, we know that F is equal to m times a, or m dv dt, the rate of change of velocity with respect to time. Very well, m dv dt is equal to mg minus kv. Well, as you can see, we can write a differential equation using the relation that we have. The differential equation is written as dv dt plus kv divided by m equals to g. So let us get back to our example here. We have a nice formula. Our job is to solve this differential equation. Is this a separable differential equation? Let's check to see if we can write this in separate form. dv over dt is equal to g minus kv over m. So dv divided by g minus k over mv is equal to dt. As you can see, we have a separable differential equation. We just need to take the integral of both sides. For this integral, you can use substitution. U equals to g minus k over mv. So du becomes negative k over m dv. So the integral on the left-hand side becomes negative m over k ln of absolute value of g minus k over mv equals to t plus c sub 1. ln of absolute value of g minus k over mv is equal to, we can divide both sides by negative k over by negative m over k, or just multiply by negative k over m. So this guy becomes negative k over m t, and this new constant, let's call it c sub 2. G minus k over mv is equal to e to the power negative k over m t times e to power c sub 2. Let us call it, for example, c. So our negative k over mv becomes c e to negative k over mt minus g, or just let's multiply everything by and call it c sub 3, because eventually we have to simplify this. We get v equals to c sub 4, or just c e to negative k over mt, and we get plus gm over k. This is a function of velocity based on time t. Please note that k is the constant of proportionality.